Hello and welcome to another Dauntless development video. Um, this is going to be part 3 in the FPS tutorial series and the second half of looking at specifically making a gun. For the last time we looked at raycasting and using basically a laser for a weapon, and this time we're going to be looking at physical projectiles. So these will have physics enabled on them, so you can do things like make the bullets bounce, etc. So let's get started. So just to kind of recap where we left off, we have our ray gun script, which we're not going to be using this time. Shootable target script, which allows the target to take damage. And we've still got our player movement that we made in the first episode. So this over here is the target, this cube. It has 10 health, and we just get a console output to say when they take damage, which you can see here. So what we've got to do now is we've got to make our new gun script. So we're going to leave this one alone here, this ray gun, and we're going to make a new script, and we're going to call it Projectile Gun. And this will fire projectiles. So I'm going to open this up. Now, this will need a few things. So it's going to be firing a physical object. So we need to tell it what that thing is. So we're going to make a public public game object, and we're going to call it Projectile Prefab. Now, what we're doing is we're going to make, if you're not familiar with what a prefab is, a prefab is basically, it's something that you've already made and you've saved in your assets folder in Unity that you can then spawn into the world at will using the instantiate command. Instantiate function. So this is, we'll store a copy of the projectile we'll make in this slot here. Now, what we need to do is we need to take, we also, just like we did last time, we're going to need a reference to the gun end. So we're going to say public transform gun end. And this means this is where the projectile will spawn from and fire out of. Otherwise, if we spawned it like inside the gun, then if we've got physics enabled, it could cause some weird collision errors, and it might not come out of the actual barrel. Obviously, when you have a proper model, the barrel might be in a different place to the center of the weapon. It's probably likely to be in a different place. So this is why you'll have a specific transform for the end of the barrel. So what we can do now is we can take the player's input. So we'll just have it simply, whenever they click, it will shoot. So if input dot get key down. So this will only happen once when they click, just like we did last time. And we'll say key code dot mouse 0. So that means left mouse button. And inside here, we will say game object. So we're going to make it, the reason we're creating a variable called of type game object is so we can then do stuff afterwards, after we instantiate. So we're going to call it, we'll call it projectile, just to keep in with the naming. Projectile, and we'll say instantiate. So equals instantiate projectile prefab. At gun end dot position, and we will give it the rotation of the gun itself. The reason for this is that means that the rotation of the projectile, if it's not spherical, will match the projectile of the weapon, the rotation of the weapon. Okay, so now we've spawned it in, so that will spawn it at the end of the barrel. But now we also need to make it move. So we'll say projectile dot get component. So whenever you use get component in Unity, you're just grabbing one of the components from the inspector on the right. So just 1 second. So like any of these, so like cube, mesh filter, mesh renderer, box collider, all these are components that you can get. So we use get component, and we will say rigid body, which we'll have to add to our prefab. And we then say add force. So this is going to add a force to the rigid body, meaning it's going to use physics. Instead of just setting a velocity, we're going to just use a force, so that means that it works well with the physics system. So we'll say add force, and then we'll use gun end dot forward, and we'll multiply it by 1,000, because obviously the forward will be a unit vector, so one force isn't a lot. I'm not sure exactly how many. I'm not sure if the conversion in Unity is like 1 unit is 1 Newton perhaps, or I'm not quite sure what it translates into, but if it is 1 Newton, then a gun clearly fires more than 1 Newton of force. So 1,000 seems reasonable. We might even want more. So this will, once we've set everything up, fire a projectile when you left click. So we need to go back over into Unity now, and we're going to need to make ourselves a projectile. So we'll start off by right clicking the hierarchy, create a 3D object. We'll use a sphere, and I'm just going to zero all the transform just so we can see it, and I'm just going to drag it up so we can look at it. Now obviously this is far too big because it's the size of the player, so we'll make it 0.1 in all directions. So it's still relatively large, but you know, it works. So we got this, and now what we can do is we need to add a rigid body, because we need to use it to add a force. So rigid body, and that, and I guess we'll name it projectile as well. So that is our projectile. So if we simply drag this into the bottom here, so we've got, this is a script folder we've got. I'm going to make a new folder inside our assets, and I'm just going to call it prefabs. And you don't need to do this, but I think it's always good to keep your files neat and tidy. So I'll drag this down into here, and now we have a little prefab. So I can delete that now from the hierarchy, but you've got to keep it inside the asset folder. So I'm going to go to the gun. I'm going to take off this. I've disabled ray gun script, and I'm adding projectile gun. So projectile prefab, I'll just grab from the assets folder. So I'll go to prefabs, and I'll drag that over, and gun end we'll simply get from the hierarchy over here. So now we have our gun that should, when we hit play, fire projectiles. So there we go. We're firing these little projectiles out, and as you can see, it bounces off the block and off the floor as well. Sometimes, if the angle's too shallow, it sometimes passes straight through. That's because you can change that, but it's because if the projectile is moving so fast, it might move quicker than Unity's physics updates can pick up on the collision. So sometimes it passes through if it's either a very narrow collision like a plane, which obviously doesn't have a very big collider, or if the speed's too high, or a combination of the two. So that was colliding off there, but you'll notice it didn't do any damage yet. So what we need to do is we need to enable it to take damage. So we're going to have to go to our shootable target script again. And in here, well, actually, here's something I should point out. what we need to do is we need to say, we need to use a function called on collision enter. And what that does is anytime there is a collision, so anytime something bumps into this, when there's two colliders, it will trigger this on collision enter, which means it'll run whatever code's inside here. Now, there is the question of, do you want to handle collisions on the projectiles or on the target itself? Now, generally, my rule is whatever there's less of, that should handle the collisions. So, because there could potentially be thousands of bullets, you don't want all of them doing collision checks all the time, because every time they bump into something, there'll be a collision check, even if it's not the things that they're supposed to damage. So instead, we'll put it inside the target, so that means if there's only one target and 100 bullets, it's only going to perform one check per 100 bullets, and if those bullets bump into each other, it's not going to call the check again. So what we can do is we need to check not only that if we have collided with something, but we need to make sure that it's actually a bullet or projectile, sorry. And at the moment, we don't really have much of a way of doing that. We can find out if the name of the projectile, so we can look at the name. However, every time you spawn a new one, you'll notice if you keep an eye on the hierarchy at the side, every time we click and spawn a new one, it's called clone. So we could check the name. That's one way of doing it. So we could say if collision dot game object dot name equals, and then we could say projectile clone, then we'll say take damage, and we'll just say 1. Now, if we do this, it should work in theory, as long as I've typed the name correctly. Yeah, there we go. So it took damage, and it's going to keep taking damage every time. So we have the collision working. It collides with it, and it takes damage. Now, there's another way of doing this. So this way, instead of relying on the name being exactly what we want, in case for some reason we have different types of projectiles, etc., we can use a tag. So I believe we've already used the tag last time when we tagged our target here. So we can use a tag for the projectile. So I'll just select it, and we could make a tag, and we could call it projectile. And we can handle it similarly to how we did last time. So we could say, first of all, I'll actually add the tag to the target. And we can say, instead of this, if the name is blah blah, we can say if the tag is projectile. And that way it doesn't matter what the name is, so we can name it whatever we want, but projectile, we can name it whatever we want, and it'll still work exactly the same. I don't think I saved that. Did I? Yeah. So we'll hit play again, and we should see that it still works exactly the same. Now, another way we can do it, which is far better, which is similar to how we did it last time, is we'll check for the component. Now, right now, the projectile has no script attached to it. So what we'll want to do is we'll want to create our projectile script itself. So we'll create a new C# script. We'll call it projectile. Of course, you can call this whatever you want, as long as it makes sense. I'm just making sure that that's typed right. Yep. So we have our projectile script. Now, what we can do is we can now do a few things in here. So first of all, this just allows us to instantly, without needing to do anything to the script, we can go over here and we can then say, we can get rid of all this, and we can say collision.gameObject.getComponent. And we can do what we did last time, and we can check to see if it's a projectile. And we say if it does not equal null, so we're just saying if there is a component there, and when you go looking for projectile, it's not just empty. So as long as it's a projectile, we'll take damage, and we'll take 1. Now, obviously, in order for this to work, we need to add the projectile script to the prefab. So I'll just go in scripts, and I'll grab this, and I'll drag it over. So now we have our projectile, and yet again, we should see it works just like before. So you can see it counting down at the bottom there. So we have we've got it working, and I mean, realistically, even checking the name, that's fine. It does the job and it works. But this is a bit more secure because you're making sure that the code that you have exactly the right type of object. Now, instead of potentially instead of taking this damage from here, what we can do is we could have our projectile have a damage value. So we could have int damage, and we'll say it equals 1. And this is typically this would be a private variable. Now, if you don't specify private or public, it is private anyway. And we'll use what is called a getter function here. So we'll say public get damage. Public int get damage. And this will return, so return damage. And this might look a bit funny, but all it is exactly the same as any other function. It's just all in one line. It's because with getters and setters, you only ever do one thing, so there's no reason to kind of take up so many lines with a single return statement. So here we are. We have this get damage. So what we can do is inside our script, once it loads, inside this, not this script, sorry, this one, we can then say take damage, and we could then get this, and we say, so we've got the component, and then we could just say get damage. And then it'll do the specified amount of damage, which is pretty effective. So yeah, so now we can do that for the damage. Now, another thing we can do is when we fire our bullets, so I'll just get back in the game. Oops, I'm upside down. So you'll notice that you keep spawning them in, but over on the hierarchy on the side, every time you fire one, you're just adding one more to the list. And even if they fall out of the world, they're still there. When they hit the actual object itself, they still exist. There is nothing happening. So, after a very long time, now this would take a very long time, but if you're in, for example, like a first-person shooter game, which this is, a lot of bullets are going to go flying. And if each individual one persists in the world and uses physics and keeps rolling around, it's going to become quite a performance problem. So what you want to do is you're going to want to give the bullets a lifespan. So what we can do is we can just have a private private float, and we'll call it time spawned, and we'll have a private float life span. And I'll just initialize this to 0, and I'll say 2f. We've got the bullets are allowed to survive for 2 seconds. So what we can do is time spawned equals time since level load. So what this will do is this will just store the time that the level. So when the bullet is first fired, it'll check how long has the game been running, and it'll store that. So then, I'm just going to delete these. I'm just going to change this to fixed update. Now, the difference between update and fixed update is fixed update only happens a certain amount of times per. Even if your frame rate is, for example, 200, this will happen still 60 times or 30 times or whatever you set the physics update to be. So this will, anytime you want to do anything with physics, you'll probably, or anything that's particularly expensive, so anything that's going to be kind of an expensive calculation or an unnecessary, something that's unnecessary to be like dead on precise with, you'll do it in fixed update just to save performance. So what we'll do is we'll just check in here if time spawned, if time dot time since level load is greater than time spawned plus lifespan. Then we will say destroy game object. So what we're doing here is we're just saying if the time now is greater than what it was before, which is time spawned plus the lifespan. So if 2 seconds have passed, destroy the object. So if you just look at this, you'll see that when we fire them, you can see them ticking away, and there we go. So now we don't have projectiles lasting forever. So that performance issue is pretty much solved. Now another thing is you might not want the bullets to bounce off things. Or you might want them to bounce off some things and not others. So for example, with this one, you might want it to just be destroyed and just do the damage when it collides with say, a person. So what you could do is when you collide with it, you could just say collision dot game object. In fact, yeah, you can just say destroy collision. Sorry, not capital C. Collision dot game object. And that means as soon as it collides with the bullet, it will destroy it. So now with this, anything that hits it is destroyed. Anything that misses is destroyed 2 seconds later. Meaning you can still have bullets kind of lying around if they miss, but if they hit their target, they'll just be destroyed. Now, obviously, this is all preference and to do with how performant your game is. If you want to leave the bullets existing, that's fine, as long as the performance can handle it. But it's all on a case-by-case basis. Now, one more thing we can do is you'll notice that if we don't destroy this, so I'll just comment out this line now, is the fact that like the bullets, if we decide that we don't want to destroy it, the bullets do bounce off it, and they bounce off everything that has a collider. Now we might want bullets to pass through things or pass through everything. So what we can do is we can just set them to be triggers. So the projectile will just tick this little box that says is trigger. Now what that means is that it will no longer actually interact, it will no longer bounce off things, but it can still trigger a message that there's been some kind of collision. Now, if we try it now, we'll see that it shouldn't work. So yeah, just passes straight through. So it is passing through just as we expected, but there is no collision detected. And that's because if we use this, if we have that trigger box text ticked, we need to say private void on trigger enter. And instead of a collision, this takes a collider for some reason. And then the structure is very similar. We'll just say if collider, oops, sorry, this one's called other, if other dot get component, we'll say projectile and we'll say, oh sorry, does not equal null, And then we can just take that line and do the exact same thing. So in this instance, sorry, we won't take that line. We'll just say other. So we'll switch that out for that. So it'll be other take damage, other.gameObject, other.get component, projectile.get damage. So it's very similar, but because we're using other, we don't need to use the game object word. So now, if we try it again, you'll see that the bullets pass straight through, but they still deal damage. So if you don't want bullets bouncing off things, then this is a way of doing that. Now, of course, just one thing to note before we wrap up is I did use get key down. So just to kind of demonstrate, if we just used get key, which wouldn't be advisable, you end up with this kind of stream. Now, of course, this is fine maybe if you've got an automatic weapon, but you typically, even if that's the case, you'll probably use get key, and then you'll check for time passing so you can have a specific fire rate. But yeah, you can see that if you had, say, automatic weapons like a light machine gun, and you are firing out this many bullets, if these did not despawn after 2 seconds, you could very quickly get into some big performance issues. So that's why a lot of those things are quite important. But yet again, that's the reason why a lot of games opt to use raycasts, which we covered last time, because there is no projectile, therefore there's no physics calculations to do, and there's nothing to get rid of afterwards. It's just point-click damage done. But yet again, it is all, it depends on the game you're working on, it depends on what your goals are. But that's all for today. So thanks for watching, and I'll see you next time.